Okay, here we are at Site 3. We're on Katoomba Creek, but in the upper part of the catchment. So we're in the top of the valley, and it's quite a small valley where we've got residential on one side and bushland on the other side. The channel here is it's quite similar to the other sites that we've been to, except here this channel is actually quite deep. So the depth of the channel is either about equal to or even greater than the width. So we're talking about a narrow channel that is a lot deeper compared to our previous sites. There's also a significant amount of weeds at this site. We've got some dominant species, we've got plenty of blackberry, lots of privet trees, lots of honeysuckle, heaps of Montbrettia. And did I mention the blackberry? There's blackberry and more blackberry. There's also broom at this site. And what's happening is that these weed species are overwhelming the native species. The native species are still persisting, but they are sort of suffering a lot of competition. And as a result, it's a very dense vegetation cover, but a lot of it is weeds. And it still provides some habitat for native animals, but it's not as great as if it was an intact sort of stream with all native riparian vegetation. Another thing that I noticed at this site is that also there's a bit of a funny smell in the water. It smells a bit different. It doesn't quite smell like sewage like some of our other sites. It sort of more smells like rubbish, or like as if dogs have peed everywhere. And I'm sure that that's just the cumulative impacts of runoff from our urban areas. It's picking up lots of pollutants that I can't see in the water, but I can smell those pollutants. So back to our channel, it's very deep. The banks are steep here. So in some places they're almost vertical. So it's quite difficult to get down into the bottom of the channel. So you sort of got to look for little spots where you can actually cross. In the channel bed, it's gravelly. There's a bit of sand in the bed as well, so that's similar to our other sites. There's no real evidence of erosion here, but you can definitely see where the flow has been when the channel has been a lot fuller as a result of rainfall. At the moment, it's probably a sort of a low to medium flow, just as a result of the rain that we've just had in the last couple of days. This channel, we've got some pools and we've got some riffles and runs, so it's quite a nice looking creek. There's also quite a few ferns on the edge growing along the banks, and as a result they create quite a bit of shading of the channel, so the shading's probably more than 50%. I can't see any aquatic vegetation, so there's no macrophytes, no algae here. Just lots and lots of ferns, but of course plenty of those weed species. So adjacent to our channel, I can see the vegetation on the hill slopes. It sort of looks like we're actually adjacent to the Blue Mountain Swamp Complex. And on the tops of the hills there, it's the Eucalyptus seberi Piperita Association. So you're sort of grading from our riparian zone here and our riparian complex into the Blue Mountain Swamp, and then into a eucalypt-dominated veg community. And those boundaries are actually quite distinctive. I think what's happening is that there's quite a bit of groundwater inflow into the creek right here, and so that's favouring the formation of those swamps, because they tend to form where you do have perched water tables, or where you've got groundwater aquifers draining into the creek. So it is quite a healthy it is a reasonably healthy stream, but it is suffering from a lot of impacts, and these impacts are probably mostly coming from upstream, like the spread of weeds and impacts on water quality. But there are a lot of houses just next to us, and their boundaries extend right down to the creek. So there's probably also a lot of direct inputs coming in as well, and that is sort of garden escapees that are pretty much escaping over people's fence lines and along into the creek. Okay, I'm now going to demonstrate to you how we're going to do a riparian vegetation assessment. So here we are on our stream. This is Katoomba Creek now. And what I'm standing in is the riparian zone. So the riparian zone includes the channel area and also the land that is adjacent to the channel, that is the floodplain, up until the edge of the valley. So you can see in the distance there, the hill slope rises up quite steeply, but it's quite flat until it gets to the hill slope. So we would consider all of this area here still part of the riparian zone. And the same would be for that side of the channel as well. So this is our riparian zone, not just this area that's covered here by the creek and the channel. So what we want to do is we want to do an assessment of the vegetation condition. And we do that by laying out a transect. So I've got here my tape measure, laid it out, going across to the edge of the riparian zone. And so I want to measure that distance and note these sorts of details down. So I'd be measuring what the width of the riparian zone is relative to the width of the channel. If you were, say, down around like Wagga Wagga or somewhere in inland Australia, you would have a very wide channel, but your riparian zone could be kilometres wide. Whereas in our headland streams like we are here, our riparian zones tend to be quite narrow and our channels also tend to be quite small. So we're probably only talking about, say, 20 metres that way, maybe only 5 to 10 metres that way, and a channel probably only maximum of 4 metres wide here. So we've laid out our transect from both sides, and now what we're going to do is estimate the vegetation cover and the types of vegetation for a distance of 2.5 metres on either side of the tape measure. And so the best way to do that is basically just put your hands out like that. So Scotty's demonstrating here a distance of about 2.5 metres to 2 metres. So it's good if you're working with somebody else doing this, because one person can be on this side of the tape measure and the other person can be on that side of the tape measure. And Scotty's just found a Barbie doll. It's a mermaid Barbie stuck in our riverbank. So there we go. We've already got a bit of evidence of human impacts here. But another thing, and the reason why I've chosen this site to do our veg transect, is because there are a lot of weed species here. So just behind me, this is a blackberry. It's an introduced species and it's got very, very sharp thorns. That's why I'm not actually too keen to go and get in there, because you just get shredded alive by this stuff. We've also got some vine. This is honeysuckle. This is also an introduced species. It's just finished flowering. There's some yellow flowers that are here on the honeysuckle vine. And what the vine is doing, and the blackberry, it's basically smothering all the native vegetation. So any poor native vegetation under there doesn't get a lot of light and basically gets out-competed. We've also got some small-leafed privets. Privets are another introduced species. These privets look like they're just about to burst into flower. Or maybe they have just finished flowering and now they've got their berries. Probably the latter. There's a few other introduced species around here. There was a broadleaf privet. There's some planted trees. That looks like a camphor laurel tree. There's a few little weeds at my feet. These are sort of like little herbs. I'm not exactly sure what they all are. And a grassy looking plant that's just behind me. So you might think that this looks like a native species, but it's actually not. When we were here just a few weeks ago, this thing was in flower and it had these bright orange flowers. This is a Montbrettia, and it seems to be really common along these riparian zones. It's basically a garden escapee. So a plant that somebody's planted in their garden and has now just escaped and is spreading its way down through our riparian areas. So we've got the Montbrettia, the small leaf privet, the blackberry, the honeysuckle, and they're all quite dense and surviving very well and trying to outcompete the native species. There are a few native species behind me. I've got some ferns. And as further as you go into the distance, there's more and more natives, or the percentage of natives increases. Broom. Oh yes, a broom there. But what you tend to find in these urban streams is that the percentage of weeds are dominant in this riparian zone. And that's because these weed seeds are being spread by transport along the creek line. So they get into the water, they flow downstream, they lodge into the bank. There's lots of nutrients here. There's of course lots of moisture, and then off they go. They go rampant. So what we're going to be doing for our vegetation assessment, we're going to be, for our distance of 2.5 meters on either side of our tape measure, we're going to be firstly estimating the percentage of cover. So we're going to estimate the percentage of canopy trees. So if I look in this direction, I basically don't have any trees, or maybe one tree in the distance. So I'd estimate my percentage canopy is probably only about 2%. Just behind our cameraman, Pete, there's not much canopy cover there either. So it's a very small, probably only a maximum of say 10%, 15% canopy cover. I'm going to now estimate the percentage understory cover, which is, there's a little bit of understory here, maybe 10 to 15%, maybe another 5%, so probably about 20%. And the percentage ground cover. Now at this site, the percentage ground cover is very high. Right behind me, it's 100% ground cover. And that's mostly because of our ferns, but also our weedy species. There's also a good cover of grass on the other side of the bank. So our ground cover was probably about 95 to 100%. Also need to estimate the percentage of vegetation that is overhanging the channel. So I sort of look around in my transect here, and I'd say maybe about 15, 20%. What do you think, Scotty?
Yeah, it's not high.
Not high. No, it's about 15 to 20%. What I now need to do is estimate the percentage of that vegetation that is native species. So for my vegetation cover, I've got one native species there, another native species, and an introduced species. So it's probably that about, say, 60% is native and 40% is weed. For the understory, probably about maybe only 5 to 10% is native, the rest is weeds. And for the ground cover, it's probably about 60 to 70%. Oh no, there's quite a few natives, so it's probably about 50-50. 50% weeds, 50% natives. I've identified the dominant weed species, so I note those down. And then I'm looking at the percentage of debris in terms of leaf litter. Leaf litter, probably only about 5%. Presence of dead trees, no dead trees in our transect. Hollow bearing trees, none, so absent. And large woody debris in the channel. So there's none of that either. So what we would do based on those percentages is then now calculate a score which helps us determine the riparian condition. So what you'll do is you'll be taking these percentages and you'll be calculating those scores for the riparian condition for this particular transect.